The next topic we are going to start with is symbolic mathematics. Now, MATLAB's symbolic capability is based on the MUPAD software originally produced by SciencePhase Software. SciencePhase was purchased by the MathWorks in 2008. The MUPAD engine is part of the symbolic toolbox. The MUPAD notebook is created by just typing MUPAD at command prompt. Now, how to create symbolic variables? Symbolic mathematics is used regularly in maths, engineering, and science classes. It is often preferable to manipulate equations symbolically before substituting values for variables. Before solving any equation, there is a need to create some symbolic variables. Simple symbolic variables can be created in two ways. First is to create the symbolic variable, just type x equals to sym of x, or secondly you can just type syms of x in the command window. Both techniques set the character x equal to the symbolic variable x. You must note one thing, that in the workspace window, both x and y are listed as symbolic variables and the array size for each is 1 × 1. The syms command is particularly convenient because it can be used to create multiple symbolic variables at the same time. The sym function can also be used to create either an entire expression or an entire equation. Next is symbolic plotting. First is ezplot, or we can say ezplot function. The symbolic toolbox includes a group of functions that allow you to plot symbolic functions. The most basic is ezplot. There are various other plots. The 3D surface plotting functions like ezmesh, ezmeshc, ezsurf, and ezsurfc are used that mirror the functions used in numeric plotting options. I have drawn the figure, that is 4 sub-figures in the same figure window for all these functions. Next is differentiation. The function called diff is used to find the derivative of a symbolic expression. If you want to find the velocity of a we can say like object, you can just write the velocity equals to diff of distance. As we all know, velocity is the derivative of distance. You can also calculate the acceleration of the object by finding the derivative of velocity. So you can write acceleration is equals to diff of velocity. So this is how we can find the derivative of symbolic expression. Next is integration. Int function is used to find the integral of a symbolic expression. Just write simple programs in the command window to go through the operations of these functions. Next is differential equation. Differential equations contain both the dependent variables and its derivative with respect to the independent variables. The symbolic toolbox includes a function called dsolve that solves differential equations, that is, it solves for y in terms of t. I have solved various differential equations in the right side. Next is how to convert expressions to functions. To convert expressions to functions, MATLAB function command is used. This can convert a symbolic expression into an anonymous function. Right? I have written the simple program for the same. You can try it in the command window. So this is all. Thanks.